Hi, my name is Yoshio Matsumoto from AIST Japan. Thank you for coming to Robotic workshop at Harris Conference. Today, let me share our experience and knowledge with you on the development of and interaction of robotic devices for elderly care in Japan. Firstly, I will mention the reason why we need assistive robots for elderly care in Japan. So we are facing is a super-aged society, as you may know. The aging ratio is getting closer to 30% now, and eventually we are expecting that it will reach 40% in 2050 or 60. Actually, the high aging ratio is not a problem only in Japan. As you can see in this graph, other countries such as Germany, Korea, and China are following Japan with 20 or 30 years delay. Another reason why we need assistive robots in Japan is that the physical burden of caregiver is severely high. For example, manual care is still regarded to be good, and most of the transfers of the patient from a bed to a wheelchair is performed in this manner. As the result, it is known that more than 60% or nearly 90% of caregivers have backache or back injury problems. Due to such hard work, the job separation ratio of caregiver is relatively high, and the Japanese government expects that we will be in short of caregivers by nearly 400,000 people in 2025. In order to keep the same level in elderly care, we have to improve uh, the care services and also suppress the number of elderly people who need care. So, and we believe that robotics technologies can contribute to such goals by improving physical burden of caregivers, improving the efficiency of care services, and by suppressing the activities of elderly people and increasing the activities and participation. This graph shows the number of welfare devices users in long-term care insurance system in Japan. I am analyzing the nationwide long-term care insurance receipt, a kind of big data to investigate the usage of devices. As you can see, in 2006, care beds and wheelchairs used to be the most popular devices used by elderly persons. However, in recent years, the use of handrails and walkers has been increased rapidly. They are useful devices for supporting independent living of elderly people who are eligible for long-term care insurance. So in 2013, Japanese government started a project to promote the development and introduction of robotics devices for nursing care called Robot Care Project. And the companies making robotic devices uh, could get a subsidy from the government. Uh, And they develop robotic devices for nursing care that fulfill the criteria categorized in the priority areas. So this is what they call priority areas of technologies, robotic technologies in nursing care. The first one is transfer aids, and the second one is mobility aids, and the third one is toileting and bathing aids, and the fourth one is safety monitoring systems. Also, the government added 4 more categories later. This is the mobility aids, wearable type, and toileting support for sensing and motion, and communication robots, and IT platform systems to improve the care services based on data from robots and sensors. And we participated in this project to make the evaluation methods and standards for safety benefits, and so we have been involved in the project for nearly 10 years. And these are the list of devices commercialized from the project. So nearly 100 companies participated in the project. So there were 100 prototypes, and about 20 devices have been commercialized. So you can buy off the shelf. These are examples of devices commercialized from the project. This one is transfer aids in non-wearable type, and this is what is called robotic bed Rishone by Panasonic. The half of the bed transforms into a wheelchair, so you don't have to make a transfer of the patient. And this is safety monitoring sensors. As you can see, the white box on the wall detecting the 3D information on the bed area, and it gives an alert to the caregivers when the person on the bed is going to fall off the bed, or when the person is leaving the bed by himself. And this is a motorized walker for outdoor environment. When the person is going to walk up the hill, then the electric motor gives assistance, and when walking down the hill, then automatic braking works for safety. And also the device, this motorized walker has GPS function, so you can record where you walked and also visualize how much activities you had in last week or last month or so on and so on. And in 2016, some of the motorized walkers was approved as welfare devices in Japan, covered by long-term care insurance. And that means each user have to pay just 10% of the cost for the rental use. That they have to pay like 5 euros or $5 every month. And as I mentioned, I'm analyzing the care receipt information, and we found that there are about 2,000 or 3,000 users in Japan who use these motorized walkers. And the ratio of motorized walker is about 0.5% in all walkers. And also we can see that the users, there are some regions where there are many users, like these red areas, and so it depends on the region. So now in the long-term care insurance system, there are these robotic devices covered by the insurance. And now I will mention how to evaluate the benefits of robotic devices. So it is very important to show the evidence of how useful and what kind of benefits you can get from the robot. And for the robotic bed, the company shows these kind of evidences that number of care staffs needed for making transfer can be reduced, and also the time to make a transfer can be reduced compared with the conventional hoist. And for the bed monitoring devices, it was shown that number of room visit at night by nurse call can be reduced, and number of accidents can be also reduced. And actually in 2018, an incentive was introduced for care facilities where they installed bed monitoring devices in each room. And this graph shows the effect of devices on the elderly persons. The previous slide shows the effects on the care staffs, and this one is the effects on the elderly persons. And it is showing that these graphs are showing the transition of walkers users in care level 2 based on the receipt information. And care level 2 in Japan indicates that the person has difficulties in rising and gait, partial or complete support needed in toileting and bathing, and so on. And the left graph shows that the transition of no welfare device users. So it's some kind of typical or conventional used elderly person. And after 5 years, about 40% died, and 14% of the people are hospitalized. And and the red this red area indicates that they are living in care institution, and the blue area indicates that they are staying at home. And in the right figure, you can see the the transition of worker users. So the ratio of died and also hospitalized persons are almost the same, but you can see that the people living at home is much more than the no welfare device users. And actually, you can see that the worker users had lower ratio of hospitalization and higher ratio of living at home. And also, worker users had higher ratio of living or keeping the same care level. This is the technologies developed to measure the performance of assistive robots. This blue humanoid robot is a simulator of caregiver developed in our institute. And the device in the back in light blue is an assistive device for transfer support in exoskeleton type. The robot performs the care motion and measures the performance of the assistive device. It is actually difficult for human subject to tell how much assistance you are getting from the assistive device. However, the robot simulator can measure and estimate the force or torque given from the device in objective manner. And this is another human-shaped simulator using robotic technologies, simulating a care receiver, the elderly person. The simulator is lying on the robotic bed, which transforms into a wheelchair. When it transforms into a wheelchair, it is known that shear forces are generated and applied to the human body, especially in the back and buttock part. And this simulator has 4 sensors in the buttock part, and it has bones and muscles and fat and skin layer, as you can see, and it can measure such forces generated and applied to the body. And so we measure such forces with different types of robotic bed, and it turned out that the second version, improved version of the robotic bed, has less peaks regarding the force. So we can say that it is more safe to the body. And next I will mention about the safety of the robotic devices. So for the safety issue, AISD have built a robotic safety center in which many testing equipments are installed. So in this facility, EMC test area, mechanical durability test area, and collision test area, and traveling safety test area are shown in these pictures. And now you can the companies can take their prototypes or products to make such kind of test. And in 2014, international standard for robot safety were issued, and now 16 products have been certified. However, we still have difficulties. The Japanese companies have difficulties in exporting such robotic devices for elderly care to other countries because EU and USA has their own safety standards like CE marking and FDA, and Japan has different regulations, and so many of the devices are regarded as medical devices in European countries and United States. So we have to, the companies have to clear these regulations in addition to the ISO robot safety standards. Okay, and lastly, I will mention the technology assessment from users' viewpoint for social implementation. So, as I mentioned, some of the robotic devices are now covered, financially covered by the Japanese long-term care insurance systems, and they have to pay only 10% of the cost. But still, not many users exist in Japan. And we are also investigating what kind of systems, social systems they have in other countries. And for example, in Denmark, we found that they have their own assessment frameworks depending on the municipalities. And in Denmark, the municipalities has the budget for installing the devices, and they can make an assessment by themselves and decide if they installed the devices in the real care facilities run by the municipalities. And the important systems we found was that they have good ways to share knowledge. And in Denmark, they have this kind of website in which you can find in which municipalities they tested the robotic, not only the robotics, but technologies, welfare technologies for care. And you can find the Japanese seal robot called Paro in this web database. And unfortunately, the website is made in only Danish language, and this is the translation by Google Translate. But anyway, it is this kind of information systems is very helpful when they make a decision on whether or not to use or install these new technologies. So let me conclude my presentation. In Japan, robotic devices for elderly care are expected to improve the care services and promote independent living. And subsidies for developing robotic devices are conducted in last 10 years. And some of robotic devices are certified as welfare devices in long-term care insurance systems. But unfortunately, there are not many users yet. So the issues to solve, one is the evaluation of benefits and safety, and it is important, but still on the way. And the systems to share knowledge, especially from the user's viewpoint, is very important for future dissemination. Thank you very much for your attention.